Hey guys, welcome back to chapter 15. What we're going to do now is take a turn away from these ice tables and mathing, and we're going to talk about a concept called Le Chatelier's principle. Le Chatelier's principle is going to give us the opportunity to disturb or manipulate a system that's at equilibrium. So when a chemical system is at equilibrium and it's disturbed, the system will shift in the direction to minimize the disturbance. So we are going to mess with these equations or with these systems at equilibrium, and we're going to predict which way the equilibrium will shift. Will it shift and produce more of the product? Or will it shift and produce more of the reactant or shift back towards the reactants? Thinking about why this might be useful, and I'll refer back to this as we go through this show, think about industry. So let's say that you are making some sort of product for money, obviously, for a profit. And there's this side reaction going on that's taking some of your product away from you. Well, it might be kind of helpful to know how to disrupt that side reaction that's happening and make it happen less often. So stop using up my product in this side reaction and give me more product to make money on, right? Or there may be a product that you're trying to form, but it's just forming so little that you're not making any money. So how can I disrupt the equilibrium so that my reaction pushes forward and it makes more product than it has been making? So this principle is a very useful principle for people that work in industry. So if a system is in equilibrium and then we apply a stress, it will shift to relieve that stress. So I like to think of a balance here, okay? So if we are at equilibrium, okay, and I apply extra weight to the product side. So I apply some extra weights over here. What's going to happen to this balance? It's going to get heavier on the product side, right? It's going to kind of shift. So what chemistry is going to do is it's going to say, wow, I've got way too much weight on this product side. Let me push towards the reactants to relieve this stress. So it's going to push towards the reactants and try to reestablish an equilibrium. Okay, reestablish this horizontal balance. Okay. So if you can picture this, whatever side feels heavy, whatever side fell to the ground, your equilibrium will shift to relieve that stress, will shift in the opposite direction. There will be a change to the system. So the rate of the forward or the rate of the reverse will be affected. But once this equation finds its new equilibrium, it finds its new horizontal, that equilibrium will be reestablished, and so it will return to that horizontal place. But we're going to be able to predict how it shifts. Okay. So we're going to look at, there's three that the textbook proposes. We're not going to look at the middle one. We're just going to focus on concentration and temperature. Okay. So effect of the concentration. So if you think about a chemical reaction, there is multiple ways that we could change the concentration. So we could add one of the reactants. So we could increase the concentration or increase the amount of one of the reactants. That's certainly going to cause a stress. We could increase or add the amount of product that we have. and that would apply a stress to the other side. So that's the easiest one to think about. But the other thing we could do is remove some of the reactant. So if you think about this balance, if I remove some of this reactant, what's going to happen to this balance? Yeah, this side's going to feel heavy because this side got lighter. So certainly removing some of the reactants could cause the shift, or we could remove some of the products. So as we produce it, maybe catch it in a container and take it somewhere else. Okay, so these are the 4 that we're going to talk about. All right, so here is our equilibrium. So we've got our balance. On this side, we've got our NO2. On this side, we've got our N2O4, and we are at equilibrium. Okay. So what will happen if we add extra N2O4? So I'm going to add some more of this into the beaker. Okay. Which side of this balance is going to feel heavy? Yeah, this side's going to feel heavy, right? So if we add more weight to that side, this guy's going to fall to the floor, and this guy's going to raise up to the sky. Okay? So this side is going to feel the stress. It's going to feel heavy. So what will happen? It's going to push us towards the products. It's going to go, whoa, I have way too much of my reactant. Let me make some more of my product to bring me back to equilibrium. Okay. So what's going to happen here is the effect of adding a reactant will shift the equilibrium towards the products. Okay. All right, so what's going to happen if we add a product? So same kind of scenario here. We've got our balance, NO2, N2O4, and this time we're going to add extra NO2. So we're going to add weight to this side. What's going to happen to our balance? Yep. This side's going to get heavy. This side's going to get light. Okay. So now the stress, now the heaviness is felt on the product side. So it's going to go, whoa, we've got way too much products. Let me shift back towards the reactants to find our equilibrium, okay, to find our horizontal. So adding extra products shifts the equilibrium towards the reactant. Okay. So what will happen if we remove one of our reactants? Okay. So let's set up another balance here. Okay. So we've got our reactants on this side, our products on this side. So I'm going to remove some of the reactants. What's going to happen to the reactant side? Is it going to feel heavy or is it going to feel light? Yeah, if I take some of those reactants off, it's going to feel light. So this is what's going to happen to the balance, right? Reactant side got lighter. So the products are feeling the stress. The products are feeling heavy. So if I remove the reactants, which way is this going to push? Yeah, towards the reactants. So the effect of removing a reactant will shift the equilibrium towards whatever it is that we removed. Okay. What about the opposite? Set up our balance. Okay. So in this case, we're removing our products. We're going to take some of this away. So let's say our product is made and that's what we make money on. So we collect some of it and we remove that container and we start collecting some more. So what's going to happen to our balance? What's it going to feel like? Yep, our balance is going to tilt, right? So if we remove some of our product, it's going to tilt like this. Okay. No, just kidding, making sure you're paying attention. If we remove some of our product, it's going to tilt like this. So our product side is going to feel heavy. And what's this reaction going to do? It's going to say, whoa, you removed those products. I guess I need to make some more. So it's going to push towards the products. So the effect of removing a product shifts it towards the products. Okay. So let's pause and think about how this would be helpful in industry. So if this is the product that I'm trying to make and I make money on that product, but my boss says, you know what, you're not making enough. I'm going to need you to make more of that product. One of the simple engineering fixes that I can use is that as this gets created, as we produce that, to remove it right away. So we produce it, remove it, that shifts our balance. It's going to make more. We produce it, remove it, our balance is going to shift, and then it makes more. So that could be a really quick engineering solution to making more of our product without affecting anything else. Okay. So this is that part that we're not going over. Now we're going to talk about temperature. So if you guys are comfortable with this idea of removing products or removing reactants, this effect of temperature, or adding products and adding reactants, this effect of temperature is actually going to be pretty easy, okay? So looking at this reaction is an exothermic reaction. How do I know it's exothermic? Because the enthalpy change for this reaction is a negative. So enthalpy is, let's say, negative 100 kilojoules. So exothermic tells me that energy is exiting the system. In an exothermic reaction, let's consider heat to be a product. Okay? So if heat is exiting the system, it's leaving the system with the products. So heat is considered a product. So if heat is considered a product, now we can think about increasing the temperature and decreasing the temperature from the perspective of adding a product and removing a product. Okay. It's a big jump I made. So if I increase the temperature, so increasing the temperature is going to add heat, we're essentially adding a product. So we've got our balance. And if I increase the temperature for exothermic, that's going to be like increasing the product. So the balance is going to look something like this. Well, what is that going to do to this reaction? It's going to feel heavy or feel stressed on the product side. So it's going to push towards the reactants. Okay. What if I decrease the energy for an exothermic reaction? So decreasing the energy temperature for an exothermic reaction is essentially removing one of the products. So we reach in, we grab the heat, we take it away. So if this is our balance and we remove some of these products, what's going to happen? the balance is going to go like this. All of a sudden, the products will feel light. The reactants will feel heavy. So by decreasing it, we'll push the reaction towards the products. So again, if ammonia was a product that I was interested in making money off of, and my boss said, you're not making enough ammonia, counterintuitively, I could decrease the temperature of this reaction and it would push the equilibrium towards the products. It would help this reaction make more of the NH3. Okay. So that's an exothermic reaction. The other scenario is an endothermic reaction. So in an endothermic reaction, your delta H is going to be a positive number. So let's say it's positive 57. I don't know. Okay. So in an endothermic reaction, heat is entering the system. So we have to put heat in to make this reaction happen. So if we have to put heat in to make this reaction happen, we can think of heat as a reactant. We've got to put it in there in order for this to work, to move forward. Okay. All right. So if heat is now a reactant, we can still think about increasing and decreasing the temperature. So if I decrease the temperature, I am removing a reactant. So if I remove the reactant, this side is going to feel light. This side is going to feel heavy, right? So it's going to push towards whatever I'm removing. So I'm removing a reactant. It's going to push back towards the reactants. Okay. If I increase the temperature of an endothermic reaction, that's essentially adding weight to the reactant side. So when I add weight to the reactant side, reactants are going to feel heavy, products are going to feel light. So this is going to push towards the products. Okay. So for endo and exothermic reactions, or for temperature changes in Le Chatelier's principle, you've got to place heat as a reactant, or you have to place heat as a product, and then think about what temperature would do. Would it add or would it take away from that side? Okay. That is the end of chapter 15. That's it. Happy studying. I hope you guys found this helpful.